intercommunication system classic. So maybe tomorrow we will discuss, or Saturday we will discuss the classic SITS communication system, right? And then we will see the differences at the same time in the last 1 hour or so. So differences, everything is same, only technologically electronic is advanced, software is advanced. So there is a changes in a system, right? Nothing great. So this is how we will proceed. Then we will have a cockpit door surveillance system, entertainment system, and maintenance. Right. So communication system, we use a radio communication system in aircraft. These are all elements for the communication system. Just to introduce you. For the voice communication system, we have HF1, HF2, VHF1, 2, 3, 5 radio receivers are available. We can use any one of them as appropriate at any time. 2 are on HF. As we have seen yesterday, VHF3 is normally on data communication system. VHF3 is normally on data communication system. VHF1 and VHF2 is on voice communication system, right? Then we have RMPs for communication purpose, FMGCs for navigation tuning. So this area we will discuss in chapter 30 or discuss in chapter 34, right? This is an audio control panel is available, which is connected with the audio management unit for audio integration purpose. Audio integration purpose means this is one computer which collect the audio from all sources, pilot, co-pilot, right? CVR, it provide the information, cell call, it get the information. So everywhere it get the information, audio management unit, and it prioritize, amplify, switching, it do a lot of things, correct? So that is the job. We will discuss about them. Cell call is there, call panel is there, right? So all these components we'll see one by one. Right, sir? Now, you all must have seen this in your aircraft. In the nose landing gear, in front of nose landing gear, there is an external power receptacle. And in external power receptacle, there is a function for flight interphone, right? So maintenance people or ground handlers talk to the cockpit directly from this flight interphone jack. There is a light in case cockpit is calling, so light will come, or ground can call cockpit just to give them alarm. Ground can call cockpit by pressing this cockpit call button. Reset is in case cockpit is calling, correct? So that process also we will discuss in detail today, as well as in SITS also it is there many places. Right. Now, how the system work? How the system work? So here is 3 components are there. Radio management panel, audio control panel, trans receiver, and antenna. Okay, it's a general diagram, general layout for everything, whether it is HF, whether it is a VHF. Okay. Now what happened in this case? First of all, whichever system you want to use, you have to choose on the radio management panel. So radio management panel is having an on-off button, first of all, where you can put it on or put it off. On the instrument itself, there's a on-off button. It has got the 2 display windows, active and standby. 2 display windows are there for frequency, active, and one rotary knob is there, which is used to select the required frequency. So When you want to tune a particular frequency, you rotate this knob after selection of respective system. For example, VHF1 is selected now because the light is on. Okay, VHF1 is selected, so you can change the required VHF1 frequency on which you want to talk. Because as a captain, you need to know on which frequency I'm going to talk. It is as good as which FM station you want to listen. Are you getting me, guys?
Yeah.
If you have
Yes.
to enjoy the music on a particular FM channel, you tune that channel. So same thing I'm going to do here. So I will choose the frequency on which I want to talk. So that frequency will be selected and it will be displayed in the standby window. It will be displayed by standby window. It is not active. It will be active when you transfer this. So when you transfer this frequency, now this become active. So let us say you put 119 here. So what happen? 119 will come here by pressing this button. Correct. Window will show you 119.00. Right. And here the same frequency will come. So now this frequency 1190 will go to receiver. It will go to trans receiver. And the trans receiver will do the functions of modulation and demodulation. If it is transmitting outside, it will do the modulation, right? And if it is coming back to receive, it will do demodulation, right? It is an electronic term. It is an electronic term, modulation and demodulation. Why we use the modulation demodulation? It's electronic processing. If you send the signal outside, you have to mix your audio frequency with carrier frequency. When we are receiving carrier and audio frequency, so we have to remove the carrier frequency. Correct? Because our audio range is very less, 20 to 20 kilohertz, and our audible frequency, understandable frequency is hardly up to 3000 hertz. Understanding and listening, they are the two differences. Understanding and listening. You can listen up to 20,000 hertz, but you may not understand. You getting my point? The mosquito sound you can hear. It is a very high frequency, but you can't understand it. So our understanding range is hardly 3000 hertz, only hertz. So that is our audio frequency, and that audio frequency is mixed with frequency which is called as a carrier frequency. So you call it a VHF, very high frequency. Okay, so this process of mixing and filtering is called as a modulation and demodulation. When you transmit the signal, you modulate. When you receive the signal, you demodulate. Okay, anyway, it's a electronics. You need not to worry about it. So that job is done by trans receiver. Correct? So once your frequency which you tuned here, it will be given to receiver, and receiver will tune on that frequency. What it will do, let us see. Now, on this tuned frequency, it will keep on receiving the signal. And once it receives the signal, it will send it to the audio management unit. Right? It will send it to audio management unit. Now, audio management unit, with the help of audio control panel, this will control the audio. ACP, it will do the audio control. So audio control, how it will perform? Because it has got the transmission and reception function. It has got transmission and reception function. So let me first introduce you to the audio control panel, then we will talk about it. So this area is clear, gentlemen, up to this point? Up to this point only.
Yes.
Right? You have 5 receivers, VHF1, VHF2, VHF3, HF1, HF2. Cell light will be there. We will discuss when the priorities are violated. So in VHF, we will see this cell light. Just understand the basic things. Now, audio, you have these top buttons. And below them, receiver name is written VHF1, VHF2, VHF3, HF1, HF2, right? Interphone, cabin, correct? So these top buttons are transmission buttons. If you want to transmit your audio, then you have to press this respective button. Are you listening me, Danuka?
Yes, sir.
Yes.
Okay, so if you want to transmit your audio, then you have to press this button. But you want to only receive audio, you can press these buttons. These are the potentiometer knobs, volume control. So just push it. If they are spring loaded, push it, it will pop out and then adjust the volume. Okay. And then adjust the volume. It's a simple. So in present scenario, what they have done, he has pressed the transmission button for VHF1 and press the reception button for VHF1. You can see the light is illuminated here. These are not illuminated. Clear? So they are connected on VHF1. So they will transmit and listen both. Okay.
फिर लेके आओ फिर एक बार
They will transmit and receive both. They will do the same functions. Now, beauty here is if you
बताओ
are
जो
trans
दाल ले आओ जो दिल करे आप ऊपर से पूछो ऊपर महंगा है मगर
the beauty here is the transmit button, you can only press one button at a time. If you have to transmit, you can transmit only on one channel. But you can listen the audio from any channel, multiple channel also. Mr. Asif, can you mute yourself? Mr. Asif, can you mute yourself?
yes sir
Okay. So transmission button, you will press only one at a time. Okay. But reception button, you can press multiple. You can receive the signal from many channels, but transmission is possible only through one channel. Is it clear?
Yes.
So these buttons which you see here, VHF1, VHF2, VHF3, HF1, HF2, 5. Then this is for the mechanical call, means ground call, mechanic call, or interphone. This is attendant, cabin crew. So cabin attendant call, right? This is a. So these are dedicated for a particular channels. This is on voice and reset. So I will put the on voice with this, which I'm not going to talk now. I'm not going to talk now. This is a part of navigation system. Okay. This is a part of navigation system, chapter 34. So this also the same thing, navigation. So that we will discuss in the navigation chapter. Clear? Hello.
yes
Yes,
sir
Yes, clear.
Right. Now, these are the PA buttons. PA means whenever pilot want to transmit the announcement in the cockpit, he can use these two buttons. He has a many ways. One of them is this. He has a multiple ways to do that. But this is one of them. He will transmit this PA button and he will receive. So he can press the receiver also. There is a INT and radio toggle switch is there. INT and radio toggle switch. So INT is a position, INT position, it is a stable position. Middle, it is a off, and radio, it is an unstable position. Unstable means it is a spring loaded to off. So you have to bring it down and hold it if you want to use it, right? There is an alternate available that I will show you once we start other topic. But if you want to use this one, then you have to put it and hold it on radio. Otherwise, it will go back on center, which is off. Else, you can keep it always on INT. That is a stable position. Clear?
Yes.
Okay. Now, audio management unit.
So, can I interrupt with a small?
Yeah, please.
Yeah, at INT position, can you still transmit?
Yes, but it is not radio, it is interphone. It means
Okay, got it.
you can use these services, but not these. These are radio. VHF1, VHF2, VHF3,
Okay,
HF1,
yeah.
HF2. This you are transmitting out of aircraft,
Okay,
right? And
got it.
INT means internal communication in the aircraft. So you can use the mechanical call, flight interphone, cabin crew call, service interphone. So all they are connected by INT. Right? But if you want to call the ATC tower, your company office, then you have to be on radio. Right, sir?
Yes.
Okay. Speech communications. So radio management panel interfaces. We have a two RMPs, RMP1, RMP2. They have the two communication buses. They are connected with the VHF1 and VHF2. Right? Three dialog buses are used for exchange of information between three RMPs. It means all the RMPs are connected together. All the RMPs are connected together. If you see the diagram, RMP1 is connected to the respective side, as well as RMP1 is also connected to the opposite side by another communication bus. Similarly, RMP2 is connected to its own side, number 2 and number 2, while RMP2 is connected to opposite side, sorry. It means you can tune any of these devices, any of these receiver from any of these three RMPs. Any of these three RMPs you can use to tune any of the receiver. Clear? It is not necessary that RMP1 is used for the pilot, RMP2 is used for the first officer, RMP3 is standby or data. No. All the three RMPs are free to use to tune any receiver.
VHF1 and HF1 is not connected to RMP1.
Which one?
VHF1 and HF1.
They are connected. You can tune
No.
HF1 from RMP1, or you can tune. What you are saying is a dedications. Dedications means normally they are not connected, but you can tune and you can connect it. Dedication is HF1 is connected with RMP1. This is the standard connection always.
VHF3 is not connected to RMP1. VHF3 is not connected to RMP1.
VHF3.
Yeah.
It is
It's only
connected
to RMP2.
Hello? No.
Yes.
I think the diagram it's not clear.
Ah,
Right?
okay.
Diagram it's not clear, but you can. Practically, if you go to the cockpit, you can tune it.
Okay.
I
If
can
I
see the dialog bus between these two.
I can, if I connect this line like this, then it is possible.
Yeah.
It is. You can tune it.
Okay.
Because what we know is, yesterday we talked about
Yeah, exact. True.
99% it is with the data connected through ATSU. Okay.
Yes.
19 points by H2 for the data transmission. So you will use only this when either this is not working or this is not working. Then only you will VHF3 for voice. Otherwise, you will not use VHF3. Got it?
Yes, exact.
But they are connected with the dialog buses through this time. And RMP3 is connected to all these receivers, not radio receivers, but communication receivers through RMP1 and RMP2. They are not, RMP3 is not directly connected to them. RMP3 is connected to VHF1, HF1, VHF2, HF2, VHF3, and RMP2. It's not directly connected to receivers. So what does it mean? If you want to use RMP3, then RMP1 has to be in position. RMP you cannot remove from the rack. You cannot remove from the position because the signal is passing through RMP1 or RMP2. Clear?
Clear. Like is that too.
Even RMP is unserviceable. Even then they has to be in their position.
Internal switching.
Correct. There is a internal switching is there. That's why they will use the buses through RMP1 or RMP2. Okay. So this is what in normal case, they are dedicated to a particular bus. So each RMP can control any radio receiver. Each RMP can control any radio receiver, but more particularly, they are dedicated how RMP1 to VHF1, RMP2 to VHF2, and RMP3 to HF1, VHF2, and VHF3. This is the normal configuration. This is normal configuration. Got it, guys?
Yes.
Okay. Mr. Anton, is it clear to you?
Yeah, thank you. It's clear.
So this is a normal configuration, and normal configuration means RMP1 is always assigned to VHF1, RMP2 is assigned to VHF2, RMP3 is assigned to HF1, HF2, or VHF3 if HF2 is installed. Now, what happens if you change the procedure? Let us say you want to tune RMP1. From RMP1, you want to tune VHF2, or you want to tune from RMP1 to HF1. What will happen? Nothing will happen. It's a very simple process. It just tell you the indication that the cell light which I've shown you here, it will illuminate on both the receivers. This cell light will illuminate. It means cell light will indicate that, hey, gentlemen, you are violating the priorities or violating the dedication. But it will not stop you to see. Light will be available on both sides, from where you are tuning and to whom you are tuning. Got it?
Got it.
In which RMP it illuminates cell?
Both RMP. Now let's say I'll give you example. You want to tune from number 1 RMP VHF 2. Okay.
Which is dedicated to RMP1, RMP2
Correct.
normally.
No.
Okay.
RMP2 is connected to VHF2. RMP1 is connected to VHF1. Now
Yes.
from RMP1, I am tuning VHF2. So
Okay.
this cell light will be available on RMP1 and RMP2 both.
Okay.
Correct?
Okay, correct.
If let's say from RMP1, I am tuning HF1. I am tuning HF1 from RMP1. Now what will happen? Can you tell me?
Same thing. Same thing because it's dedicated to RMP to RMP3.
So cell light will come on which places?
Yeah.
Which RMPs?
RMP 1 and 3.
Okay.
Yeah, RMP1 and
Yes.
Thank you, Umar. So now it is clear to you, Haitham?
yeah.
Very good. Because HF1 is dedicated on RMP3.
Okay.
Right. Simple thing, not so great. HSU uses VHF3 for data transmission. Navigation, sorry, just leave it. Maybe on Sunday, we'll talk about it. FMGC is also used for navigation purpose. Close. FMGC is also used for navigation system automatically tuned. Automatic tuning of navigation system through FMGC. So we don't need FMGC here. CFDIU. Why CFDIU is required?
Built-in test equipment.
Built-in test equipment. Why LGCIU is required? CFDIU memory, right? As well as ground and flight conditions. RMP1 receives discrete signal from LGCIU1 and RMP2 and 3 from LGCIU2. So they provide ground and flight status from LGCIU. Clear, sir? They get
Yes.
ground and flight status from LGCIU1 and LGCIU2. Sorry.
Sir, but the question is, why do they need ground status?
Very good. You
Yeah,
forgot
for-
my class. You forgot my class, which I have taught you CFDS system. Mr. Dinesh. Every computer has got a memory for fault. And the memory is divided into two parts, ground memory and flight memory. Correct?
Yes.
So who will tell that that computer is on ground or computer is in flight?
LGCI.
Yeah. That's why I told you that two computers are parasite. LGCIU and CFDIU.
CFDIU.
They are attached to all computers. They are connected to all computers. I mean, their signal is connected to all computers. CFDIU need byte information.
Yeah.
LGCIU provide ground and flight status. Clear, sir?
Yes, sir.
Very nice. Now let's talk about RMP failure. In case RMP fail, what will happen? The window will be out. How you will come to know RMP fail? There is no display on the both display windows. The display of both active and standby window will disappear. Okay. But to confirm, what you can do, there is a switch available on RMP. There is a switch available on RMP. So you can try once with this switch. Make sure this switch is on. If this RMP fail switch is on, your display will be blank. Nothing will happen. As a captain, you can try once to just put it on and off. Still it is down, then you cannot use this RMP. RMP is gone. Clear? RMP has failed. So if RMP is failed, then on-site navigation system will be lost. That means on-site navigation you cannot tune. On-site means RMP1 number one navigation system, number one receivers. RMP2 number two receivers you cannot tune. That is a problem. But communication system is available for you through the other RMPs. You can tune the receivers through other RMP. As you know that you can tune RMP2 to VHF, RMP2 to HF1, RMP to VHF1. You can tune any one of them. So your receivers are available, your communication is available, but your backup navigation is lost to the respective side. If failure occur, the failed RMP has to be switched off. When selected off, RMP send a discrete signal for system reconfiguration. System reconfiguration, it will send a signal. So it will tell other RMP that it is failed, and it will other receivers will receive signal from other RMPs. Clear, sir? So it's a simple diagram, simple dialogues. All the RMPs are connected to each other. You can see here. 1 and 2 are connected. 2 and 3 are connected. 1 and 3 are connected. You can see here. So it's a jumble. By and large, you understand that all 3 RMPs are connected together. Correct? All 3 RMPs are interfaced together. Right. Audio switching. So this is what we talk about RMP. Now let's talk about audio control panel. We have 3 audio control panel: first officer, captain, and third occupant. This is on central pedestal, this is on central pedestal, and this is on overhead panel. The location of third one is on overhead panel, 49 VU. Correct? Third RMP and third ACP are in overhead panel, 49 VU. Got it, sir? On the overhead panel, 48 VU, there is this audio switching rotary knob is there. On overhead panel, 49 VU, there is a audio switching rotary knob is there. The purpose of this knob is to connect number 3 to number 2 in case this is failed. If first officer is failed, move the switch to FO. So what happens when you move the switch to FO? Now the network is like this. So this is a captain seat, sorry, first officer seat. He has all his acoustic equipment, which is a boom set, handset, oxygen mic, right? Headphone. So all will be connected to audio control panel number 3 by just rotating the switch. But he has to make the selection from top. He cannot make the selection here. That's a problem. Got it, Mr. Dinesh?
Yes, sir. You mean if the audio panel for the first officer is enough,
Yeah.
you can select it from the audio switching. Does that mean if that hardware is not working, in case the hardware is not working and you switch onto first officer, does that mean the hardware starts working, or will you use the overhead audio panel from the first officer's audio panel?
Your both sentences are correct. See, first of all, when this is not working, then only you will use this configuration. Got my point?
Yes.
But my second question is, if this is working, sorry, if this is working, then why you will use this? Why you will
There's no-
stretch your hand?
Yeah, there's no need.
There is no need,
There's no need.
right? You will unnecessarily stretch your hand and see like this, bending your body for discomfort. So, but Technically, you can anytime move this switch and connect this to first officer. System will not stop you.
Yes.
You can normalize and you can use your first officer also. It is available in both way. But my question is why? Got it?
Yes.
So generally, when this is fill, only then he will use it. In the same way, captain side. So now in this case, it will be connected to this side. Okay. So depend upon the switch where you want to keep. The audio control panel will be connected to captain side or first officer side. I hope this is clear.
Just one question to clarify.
Mhm.
If we take the RMP for the first officer, if that RMP is enough, I mean it's not working at all. There's something wrong with that hardware.
We are talking
Okay.
about RMP or ACP.
No,
We are on ACP now.
It's not the same case.
We are on ACP now. So you are talking about RMP or ACP?
ACP.
So we are on the same page. Okay, go ahead.
If that ACP is not working at all,
Yes.
you can still use the one on the third occupant to transmit everything that you need from your side.
No. You mean to say you want to transfer the captain to this way?
Yes.
Captain ACP you want to transmit to first officer, right? Sorry, third
If-
occupant.
Yeah, third occupant.
Not
No,
possible.
that's not possible. Okay. It's only the other way around.
It's only one way.
Yeah.
Right? Because the switch is only provided for this.
Yeah.
This RMP. Sorry, this ACP. Switch is not provided for this.
Yep.
And once you do the switching here, either side, then you will get a EK message audio switching. Can you read here? If the message audio 3 transferred is displayed in the green on EK memo, right? EK memo, you know, here. This is the memo section of engine warning display page. This is a EWD. Okay. So on EWD, here you will get a message audio 3 transferred. So pilot will remember, hey, I have transferred the audio 3 or captain has transferred the audio 3. Clear?
What does it mean? The third occupant audio ACP cannot be used.
Third occupant audio. The third occupant audio equipment cannot be. Yes, because if you transfer it, if you
That
have
means-
already transferred.
Okay.
See, audio equipment. This instrument is associated with audio equipment. Audio equipment means boom set, handset, hand mic. So if you have already transferred it, to the captain's side,
You use
so he cannot, he's disconnected.
Okay. So you use handset and everything of the captain side.
Exactly.
Okay.
Thank you. Because captain and first officer is important. Third occupant rarely you will find in the cockpit.
Okay. Thank you.
If third occupant who is going in the cockpit, no one is going unless there is a training or there is a supernumerary is going. Even if supernumerary is going, he is just going as a passenger. He is not going as a flying crew. Only third occupant will be there if someone is going on test flight or training.
Okay.
And there will be a third occupant, official. Unofficially, if someone is sitting, they will not use the acoustic equipment. Why they want to be recorded in the system that someone is in the cockpit?
Yeah, I understood another way. I understood that the ACB will not be not the equipment. I forgot about the equipment.
No problem.
Okay, thank you.
Now it's clear.
Yeah, clear.
How is your friend? He was in my earlier batch
Yeah,
from Tunisia.
he's very good. He's always talking with me about you. He said you were great. Yeah,
Oh, no.
yeah.
I'm just
No, no,
trying.
no,
I'm
no.
trying
no,
to
no.
give you
Really,
information.
we miss your class. Really, all the guys. We
Thank you.
understand. Yeah, thank you.
Thank you.
That's true.
Thank you, sir. So is this clear? Should I move?
Yes.
Okay. So only one thing which you can remember here is after switching, you will get a ECAM memo message just to make the pilot aware that audio has switched. Okay. So this audio 3 transfer message will be displayed on the ECAM memo. Right. Audio management unit interfaces. So we will see the audio management interfaces. Let's first look the audio management unit. How does it look like? So this is audio management unit is a one computer. Okay. And this is located in the ATBU rack, where aft avionics rack it is located. ATBU. And now you see the interfaces, this audio management unit. Captain, first officer, third occupant, even you have a fourth occupant also. They all are connected to audio management unit. And every seat is having his own personal electronic card. 1, 2, 3, 4, etc. etc. You can read here. It is a captain card. It is a first officer card. It is a third occupant card. If you have a fourth seat also, it is a fourth occupant card. You can connect as many as you want. Right? And they all do the same job. Only thing is the hardware is connected from the respective channel. What is a hardware? Audio control panels and these things. Audio equipment, PTT switch. What is a PTT switch? That is on the side stick, push to talk. Right? As well as every equipment has a PTT. Your boom set is having a PTT. Hand mic is not having a PTT, so they use the side stick PTT. Correct? So oxygen pressure switch, everything is connected to respective channel, respective card. The purpose of this card is audio switching, volume control, filtering the signal, amplifying the signal. It means it is a complete electronic processing card. It's an electronic processing card which perform all these functions: audio switching, volume control, amplifier, etc. etc. So this is a one source of information it get. Over and above, it also get the information from other channel. What are the other channel? Your overhead panel is connected here. Audio switching. So if you are moving these audio control panel, audio management unit should know that captain is connected with number 3 audio control panel. So who will tell? This switch will tell. A discrete signal will come from the switch to audio management unit so that audio control panel 3 will be connected to the captain. Right, sir?
Okay.
Subsequently, there is a switching panel. It's electronic switching. Now, what switching it is doing? Just trace the lines for the switching. SITS line is connected, as well as all these audios. Right? All these audios are going to the switching panel. Means you have a HF, you have a VHF, you have a interphone, cabin, PA, ADSU, ADF, VOR, DME, weather radar, wind shear, EGPWS. You have a hell lot of audios available. Hell lot of audios are available. As well as you have audio also available from the flight warning computer. Means all the master questions, all the warnings coming to the FWC. Correct? So what is the priority from this loudspeaker? Which sound should go? Which sound has a priority? Maybe TICAS, maybe VOR, maybe DME, maybe wind shear,
So predictive wind shear.
maybe HF or cabin interphone. Among these two, who has a priority? I don't know.
Okay.
Warnings.
PWS.
Right? Why I am explaining it here, the priorities are defined in audio management unit. Right? That if two sources are available at the same time, or one call is going on the lower priority, higher priority sound is coming, it will suppress the lower priority and allow the higher priority sound. You got my point?
Yes.
Okay.
So audio management unit priorities are already defined. Let's say, I'll give you one example. Pilot is calling to the cabin crew, or cabin crew is calling to the pilot. Okay. At the same time, he's getting a cell call from the ground. So cell call has got the priority over cabin crew.
Yes.
If let us say you are getting a message from marker, but it comes momentarily, it's a very short time. Right. These signals, DME, ADF, VOR, marker, they are only microseconds or seconds time audio, not more than second audio. But let us say among EGPWS and PWS, you get the warning. Both are going on. Let us say EGPWS is already coming, and now you detect the wind shear. This is the right example. EGPWS warning you are already getting, which is going through the loudspeaker, and now you got the predictive wind shear. So what happened? EGPWS will be suppressed by audio management unit, and predictive wind shear warning will be routed to the loudspeaker because it has got the priority. It is more serious. So that job is also performed by audio management unit. Clear? It has got some more parts.
Sorry. Does that also have priority over attention getters?
Attention getters, you can say, but attention getters is a light which comes momentarily and then goes.
Okay. Yeah.
Right?
Yeah.
Attention getter, yes, you can say master warning because it depends upon whether it is a master question or master warning. So master warning itself is a priority over master question because they are the separate channel.
Yeah.
Right? Master
Yeah.
question and master warning, two are separate channel. Now you can say there is a two master warning. Then I have to think for the priority.
Yes. Okay.
Right? There may be a fire and there may be a wind shear.
Oh,
A very bad day.
yes.
Hypothetically, you can think anything.
Yeah.
But it's very difficult to get such kind of scenarios.
Okay, thanks.
So this is what as a job of this. Some more things are there. We will discuss subsequently. Right. Secondly, you see here the audio which is going from the audio management unit is passing through the volume control. Is passing through volume control. So you can control the volume for audio which is going from the audio management unit. Clear? But if some audio is going directly from the flight warning computer, you cannot control the audio. You cannot minimize it. Make sense?
Yes.
So these sound you cannot switch off. That's why sometimes if you switch off the loudspeaker in the cockpit, still the sound is coming. Still the sound is coming. If you perform your TCAS test, if you perform your wind shear test, you just switch it off. Right? You switch off both side loudspeaker. But still you will hear the sound. Because this is not passing through the loudspeaker control. You got it, sir? So you can see the two separate channels are going to the loudspeaker. One is from flight warning computer and another is audio management unit by volume control. These sounds can be controlled, can be adjusted, but the sound which is coming from the flight warning computer, you cannot control their volume. They will come with their own pace, predetermined level. Clear?
Clear.
Let's see if I missed something. So 3 to 5 audio identical control panels means control cards can be installed. They are linked to the airing 429 buses related to the audio cards in the audio management unit, which is I talk you about all these cards or audio control panels. There are no audio signal inside ACP. AMU layout, various functions such as switching, filtering, amplification are done inside the AMU. AMU includes several identical audio processing cards, one for each ACP. One for each ACP. ACP means audio control panel. Volume control. The volume control function is achieved by the digital transmission of knob position to the audio management unit. Volume control is achieved inside the audio management unit.
So the
this
priority.
volume,
Yeah. So
you are asking something, Yatam, to us?
yeah. So the priority example between EGP WS and wind shear, for example, is inserted inside AMU or
AMU.
AMU. Okay.
Because there is a switching card is there, it is a part of AMU.
Okay.
This is a switching card.
Okay.
This is a part of AMU only.
Yes.
Right?
Yes, right.
Okay, let's take a break, guys. And then we'll see you after 10-15 minutes.